Hello everyone. Today I am going to discuss on the gradient descent. So before start with the gradient descent, the thing the machine learning is like kind of magic, right? Because you just input the data to the computer, and it learn it and predict the new values, right? But the real problem is how to improve our machine learning model if it going wrong, okay, if predict wrong value. So how to know and how to improve it, the main challenge, right? So gradient descent is a method, or you can say the optimization engine, which helps to correct the errors or minimize the error and make the model better. Okay, so is a you can say repetitive process until you um, reduce the error to minimum level. Let's have a look. So today, as in the last video, I have discussed on the linear regression. I have shown you demo how to create a linear regression model. And in regression, we have used gradient descent to optimize our model. Basically, gradient descent use in linear regression, where you use a big data set to train our model. Okay. So, for example, here goal of the machine learning model is we want to predict marks based on the study hours, as I shown in previous lecture as well. Here also working with the same example data set, and we all know already have discussed, and you also had linear regression equation is UI equals to mx plus b. Okay, m is the slope, b is the intercept, x is the input, and y is the output, right? Now we'll discuss how gradient descent calculate and give you the right direction. Again, before starting with the calculation, I give you the real life example. Suppose you stand on top of a hill. Okay. In this case, you cannot see the edges of the hill, but you can feel the slope, right? Slope. So here you just uh, go ahead with small step and feel how to which way path you have to follow, and again go ahead step with small step, right? Your actually aim is here to reach to the lowest point. I mean, in a safe place, right? So in this way, you actually slowly move you to the lowest point. Here, gradient descent method follow the same process. Is find the error and step by step and slowly improve the uh, I mean change the improve or change the value of the parameters and go ahead and check again if and until it we reach like with a minimum error. As I shown above that linear equation is like y equals to mx plus b. But at the initial state, we don't know am value of am and b, right? But we know the value x because x is the input value. And say for this example, hours, and we have to predict the mass, right? So initially the ml knows nothing. We start with the m equals 0 and b equals to 0. So our prediction becomes y equals to 0, like that. For study hours 1, prediction 0. For 2, as well, also 0. Okay. That means it's a huge error. Actually, not able to predict because it don't know the pattern, right? Now we calculate the error and cost function. So individual errors equals to actual minus predicted, right? Here actual was 40 and previous 0, so error 40, for 50 as well 50. And cost function, how to calculate MAC, as I already discussed in the previous, I mean last lecture. So we have to square the error and take the average of all the data. Right? So square means 40 square plus 50 square. Here 40 square is 1600 and 2500, and sum it and take the average 2025. So it is the MAC. And it indicates that very bad model because value is very high. Now, so now next step is we have to make the small changes. Let's try changing m equals to 1 because the m was 0. Let's look. Now the equation is y equals to 1x and b value is 0. So that's why not we care about the b. Okay. For 40, new prediction is what? 1. New prediction is 2. Sorry, for 1, our prediction is 1 and 2 for 2. There will be new error is 3948 because actual minus new prediction 40 minus 1, 50 minus 2. The error square is this and this, and now new MAC is around 1912. So that means error reduced from 20 to 50 to 1912. So as we have changed the value of AM to 1, is the error also reduced. So increasing M reduce the error. Because error decrease, the model know it should continue increasing M in that direction. Right? This iterative process of finding the lowest point of error is the core concept behind optimization. As I said before, this is the process of gradient descent. So what is gradient? So gradient, how to calculate gradient? Actually, gradient measures the rate of change. How fast error changes when the parameter changes. So gradient um, kind of equal to like error, change in error and change in by changing parameter. This equation. So error change. The previous error was 2050 and new error is 1912. So I mean error mean MAC value. Okay. So what error change? Minus 138 and M change started with 0 and in the next step we change to 1. So M change is 1. This is a parameter change. Was the error change. Actually parameter change mean actually mean that M change in M. Now the gradient is as per the equation error change by 1 T. So a negative gradient means increase M to reduce error. Okay. If positive then decrease M reduce error will also reduce. Okay. Now the gradient value is this. Now we have to take care of the learning rate. What is it? The learning rate controls the how big the adjustment step should be. Gradient provides the direction and learning rate provides the step size. Okay. That means you if you top on the hill, your every step is the learning rate and in which direction you will walk. This is the gradient. So now the formula for calculating M, the old value of the M minus LR means learning rate into gradient. So that means old value M was 0 and gradient is this one and learning rate is 0.01. This is the standard value as I discussed previous session. So new M is 1.38. This is an automatic process. So it will only increase the M like this way. So in every iteration. Okay. So again it will calculate everything error and calculate the gradient. Okay. Again calculate the new M value. In this process it continues improving the model until the error is minimum. So why is learning rate needed? With too big learning rate, suppose error is 10, causes huge unstable jumping. The model overshoots the minimum error and fails to run. Definitely, in a top of hill, you rashly go towards any direction. This is life threatening. Same case here also. And if they're too small, teeny step update, but learning becomes very slow and inefficient. So balance thing is very good. So in the here you have taken 0.01. This is standard thing. For smooth learning, so we have to adjust this parameter. Okay, very carefully you have to adjust this parameter. Very important thing. So gradient descent cycle is like first is predict, then it calculate the error like MAC, then it calculate the gradient, then update the parameter slowly, slightly, I mean, and repeat until reduce the error, minimize. This is the whole life cycle of the gradient descent. Okay, so the real human analogy is huge mistake if you cannot hear anything. I mean, for TV volume, suppose in this example, it's a TV volume. Okay, the TV volume is too low. Okay. So here huge mistake. If you cannot hear anything at all, you increase the volume a lot. A small mistake. If it is just slightly too quiet, you increase it slightly. The mathematical truth is ML does the exact same thing mathematically using gradient and learning rate. So cost function is error calculator, measure the how bad is the model. Gradient is the improvement direction, measure how should the model improve. And learning rate is the step size, how much to improve. Okay, this is a very the major thing of any machine learning model. So that's all for today. Thank you.